Hello, this is just a quick demonstration for the virtual machine I wrote. I'll just get started right now. Back in March and April, I got interested in writing my own programming languages. And so I followed along with Robert Nystrom's beautifully created book, Crafting Interpreters, where I followed along. I converted all of his Java code into C code for the first language and then followed his stack-based virtual machine for the second language, all in C. And then I got curious and I was trying to figure out how can I make it faster because the stack is a little bit slow. And if you just move to pure registers in a virtual machine format, then it can kind of run as quickly as possible before you get into just-in-time compilation. And so what I started doing was I just wrote a virtual machine and then I wrote a bunch of tests for it in a kind of an assembly-like programming language. And it compiles on Windows. I only tested it on Windows. It can compile with CL, the developer console commands, or Clang. And so we'll just get into it right now. So you can see all these assembly instructions. It's kind of based on MIPS32, where instead of doing like R0 or R1 for the register, I do like the dollar symbol. So the dollar symbol right here, we're loading the number symbol 1000. We're loading 1000 into register 0, for example. And so these are just a bunch of tests that I run to validate that, 1000 is loaded into register 0, and I can run it. And we'll run through all those tests, and I just printf everything. I printf literally everything so I can, more thoroughly step through and debug it. There's no there's no visuals. It's just a console-based VM. And so we just ran through all of those very simple tests. And then I started getting a bit more complex, where we can step into this one, where you can see it kind of looks like assembly, where this one, we're just working with like a virtual array of memory, like 256 bytes. And the purpose of this code is that we have these two labels, hello and world. And so we're just gradually copying them. We're doing like string copy into another section of the memory. So first we copy hello over, and then we copy world over. And so if I step through it and run it, you can see that we print hello world. I even got a little print statement in there, which just dumps directly to the console. And so we can go to the next one, and then I'm testing the stack here, where I can push and pop variables onto the stack. And I spent all day fixing this up and making sure it can compile correctly. And so I didn't look over this one, but it still works correctly. Like, I guess what we're doing here is we're testing a factorial thing. We're jumping around and testing the factorial function for, like, I guess factorial 12. I can't quite remember. But we can go to the next test. And this is the Fibonacci one. I wrote two different versions of this. I commented out the old version because I realized that I could fit it all into a fewer lines of code. And so we're doing the 8th Fibonacci number, which is 21. And so, I just test down here. I assert that for all these tests, I have an assertion where I just assume like a certain value is in a certain register. And so since we're doing the 8th number of the Fibonacci sequence, we're testing that 21 will end up in that register. And it passes, so it works. And so then we're testing the frame pointer, where I kind of have like a function. Now we're calling functions with this assembly-like language, where I just load the numbers 2 and 3 into different registers, and then I push them into the stack, and then we load up this add test function where we set a new frame pointer, and then we pop off the old variables, and then we add them together, and 2 plus 3 equals 5. And so then we step into this little test down here, and we're just checking if 5 is on that stack, is in that register, and it works. And then the last one, I was working on like system calls. So like you can add a certain variable onto the register, and then you can call syscall, and then depending on the numbers, like you just need to know the hard-coded numbers for it, you can activate different things on the computer. So in this case, I was writing this whole virtual machine as like a little hidden magic system for the game I was writing. And so like I would add like English words to this later, but right now like I'm just adding these specific numbers, and that activates like cast projectile, which I can show you right here. Like you can activate a bunch of different spells, like just 3 different spells right now. But that's pretty much it. The meat and bones of this thing is execute instruction, where so I parse the strings. Ultimately, it's just a bunch of chars, and so I parse them into a bunch of different commands, and then I load them up into an array of instructions, and then I loop over that whole array gradually. And depending on the instruction, I execute a different chain of commands. And it's totally sandboxed. Like, I make sure that the memory is locked down so that you can't crash this, because if you crash the virtual machine, then you crash the game, and you don't want that. So yeah, I made this, I think I finished writing it in June, and I got sidetracked with other projects, but I just cleaned it up to submit it for this little example. So there you go. Thanks for watching. See ya.